See, I have problems with. So let's start. So first, why is wheel alignment important, and why do we need it? Everyone. So why is alignment important? So firstly, wheel alignment is directly relevant to the tire wear and how the tires is going to wear, if they're going to wear evenly or not. So you have an example on the right side of how the different wheel alignment angles affect the tire wear. So having a good alignment on the vehicle will improve the tire lifetime. So it will give the chance for the tire to roll more kilometers. It will have a direct impact on how the car is consuming gas and energy, and also how the vehicle rolls, and also its safety and characteristic like driving. If it will be easily turned, if it will be a little bit worried going straight on the road, and so on. So this is the most important, talking in alignment, what impacts the actual car and its driving. So why do we need to do alignment? So we have a few different reasons for why we need to do alignment. So it's firstly, if anything on the axles of the car has been changed or adjusted, it's always need to do a control for alignment to see how the wheels are rolling and so on. And also, if you're moving anything on the brakes or the moving parts in the car, it's always important to follow up doing an alignment to make sure that the wheels are still in the right position and so on. Or you have around 3,000 to 5,000 kilometers after the car roll 3,000 to 5,000 kilometers, or once every year, just to control. And this is directly related to keep the tire wear well, and keep, say, the gas consumption to the minimum as it's intended. It can also be had to be done if you have any accidents, if you're hitting the sidewalk, if you're driving on roads that you have a lot of potholes. This may also directly impact alignment. You have if you do any modifications of the car, if you lower the cars, if you raise the car and so on, you will have to do also an alignment control. Mute everyone. So, and currently the market is having a focus on let's say wheel service. So I want to look into this part of why wheel service is growing, and the popularity of alignment and so on is getting more attended, and we're more focused on and more interesting. So we have firstly the growing popularity of let's say EVs, electrical vehicles. It is commonly known that since you have a torch of an electric car is different, you have a different let's say consumption of the tire, so it's more rough on the tire consumption. And it said that in EV it consumes 30% more tire than a normal car, than a conventional car. So therefore, since tires and so on is expensive and it's a big cost for a car owner, it's more focused on trying to have the alignment to well, so the tires can last the lifetime they are supposed to. And also the focusing growth of alignment and wheel service in general for a workshop is that even though the cars are developing and going forward and changing and so on, what we can know for certain that even the future car will roll on wheels. So this is also a kind of a certainty for work and so on for the workshop. See, sorry guys, I will turn the video off in the meanwhile so you can see the presentation well. So it provides a certainty for work for the workshop. So to look into a few different reasons for why and shops, let's say workshops should get alignment and start to invest into this market, let's say. So they have three different reasons, or three difference that I put down. So if you don't have, it's a perfect investment because you will tap into a fast growing market. You will have the possibility to keep more work, let's say in-house. If you previously have a CCD, it's a good, you're looking for increase the use or increase the ease of use. If you work with CCD, it's a bit time consuming. It's maybe hard to set up and it takes time to actually do an alignment. So they may be looking to increase the workflow and make it easier. Therefore, it's a good chance to introduce the 3D alignment, which makes this job a bit easier. Or if you have, let's say, a 3D already, then you're probably very familiar working with alignment and you're looking to increase, let's say, the output. You want to work faster. And therefore, we have our 931 no touch, which is a good suggestion for these consumers or workshops that are looking to increase their output by the end of the day. And to go over a little bit, what are the needed setup in order to work well with alignment. So normally that the required tools is an appropriate lift, which is a 4-post lift or a scissor lift with turning tables and slide plates that are well leveled and so on. So it's stable. The most important is that the lift is leveled out and so on, that it provides a good working base for the workshop. You have sliding tables and sliding plates, and also jack lift for certain cars that needs to be lifted up and so on to do special measurement. Other tools that are helpful when working wheel alignment is diagnostic, obviously. When we have the steering wheel sensors and so on, we have to adapt. We have shaker plates, which is used to look for mechanical place and so on. If a car has a mechanical place, then it's usually no point or not possible to make alignments. You need to exchange certain parts before doing an alignment. If not, you will not get the results that you're looking for. And then obviously you have the special tools that some manufacturers are requiring. For example, Mercedes, which has their inclometer requirement. So, and just to give up an idea because normally we say that the workshops maybe they are reluctant to make an investment and so on. So I want to break this down and present it as a way of a selling concept on how I like to break it down personally. So normally it's a good way to see it is to take the cost of the alignment. Here I have a few options, which for the 861, the 931, and with the lift setup with the 861, for example. And I divided it for 3 years or 5 years cost. I divided it monthly and daily cost. So you can have a look at this idea, and this is based on let's say Europe market. So it's easily adapted to each and every different market, just to use this frame, let's say. So, and this will make sense later on, but this is what we're looking on, the daily cost if the workshop decide to invest in alignment. And this is based out of 20 working days every month. So looking at the opportunities. So as a workshop, what are the opportunities for why to invest in alignment? We have, as I said previous, the wheel service market is a growing market, and it gives a strong return on investment. It has, this is based a little bit around the, let's say, the world markets in general. So the average price range for a wheel alignment charged to the car owner is, depending on the car and the setup and what is required, is normally between 40 euros to 250 euros. Depends on the car, depends on the market, and so on. But more or less, this is the range, let's say, what we're looking for, what the workshop can charge for doing an alignment control or alignment adjustment. Another opportunity, you have the possibility to grow your clientele. You have the possibility to grow your market and the customers on who you can support and who you can give service to. And you have the great possibility to keep work in-house. Normally, when if you're a workshop, you do some changes on the car, you don't have alignment, you need to refer this customer somewhere else to do an alignment, to do a check. So this gives you also a good chance to keep more work in-house for the workshop. So here we have, looking at the breakdown as from earlier, 3 to 5 years. So this breakdown, I want to show how much it costs. So I broke it down in a weekly cost. And this one is based on an average of alignment of 80 euros per time as a charge. So if you look here at the cost, if you, for example, the customer or the workshop buys an 861 with the TLT 455W, it's going to have it's going to looking at the weekly cost for 93 euros in this case. And to make this let's say investment back and actually return on that investment, you need to do 2 alignments a week, and you will end up with a profit of 67 euros. So, and also if you go from 5 years, we can take the 931, it will have a weekly cost of 135 euros. With the 2 alignments a week, you will have a 25 euro profit of that week after paying this 135 euros. So looking at this and breaking this down, it's easier to see black and white what are the actual costs and what are the opportunities in this. And what is interesting to when talking to a workshop is to ask them how many referrals they do every week. And more often than not, the workshop, they have normally maybe 3 to 4, 5 referrals every week, which they have to refer to go somewhere else. And it's interesting to see the response when they realize they're actually giving money away. So it's a good, let's say, keep in mind sometimes when presenting the wheel alignment, because it is actually a growing and a good investment that allows for a growing opportunity like a workshop to grow. So this is the let's say the end of the first introduction session for wheel alignment in general. So we will, as I said before, we will save the questions, and if you have any questions, please feel free to write it in the group chat, and we will get to them once we are finished, so we can go over each question individually. So please, if it's any questions, just don't hesitate to ask. Okay, so let's start the second part. Okay. Let's continue. So this part will go more into the okay, so now we will go more into the basics of alignment in general, and we will start This is going to be more focused on the user and looking into the different angles and so on of the alignment. So about this course, let's say the objectives, the main goal with this is to create an understanding of what are the different angles, what are the impacts of the different angles, and so on. And what are the different, let's say, circumstances, what are the surroundings, what are the things that can impact the end result, let's say. So to begin, we have a lot of things that might impact the wheel alignment. So you have, obviously, it might be with the lift, the build up, if the lift is in level, if you have, let's say, if the run out was done perfectly, if you have the turntables, maybe they're not oiled up or they don't move properly. You have, if you have the lift are not in park, if it's not in stable position when you start, and so on. And maybe you have the tires on the car have different dimension, different brands of tires. And you have maybe the different rims have some different, let's say, offsets on the axle, or you have the tire pressure is not controlled before you start with alignment. So you have a lot of circumstances that can impact the end result and make something go wrong, let's say. So this is, let's say, yeah, this is a lot. So we're trying to break this down a little bit one by one, so we can go forward. Yes. So starting to look at the wheel angles, we have 3 different ways of how the angles can be measured. So we have minute degrees, decimal degrees, and millimeters, more or less. This is what is mostly common to use with. So if you look at minute degrees and decimal degrees, there are, I mean, you have, as you see in the chord, you have always four quarters, let's say, of the tire, so it's divided. So if you look at, I have 2 examples here that you can see. So for example, 60 minutes is 1 full degree, and 1 over 100 of 1 degree is 1 full degree. So if you measure in, so you can move forward. If you measure in millimeter, this is, let's say, normally depends when you use millimeter. The only thing the difference from when you choose from degree to millimeter is that the size of the rim, it matters, because if you have the millimeter, you are basically measuring from the edge of the rim to the other edge of the rim. So if you go on a distance, then if you have on a distance, on the example in figure 1, is that if you have a toe in, let's say, with 7-inch rim, it'll be 2.3 millimeter toe in. But if you have a 15-inch rim, it will be a 2 millimeter toe in. So on a front of 1 meter, and when you measure in millimeter, this will change, let's say, if you have toe in and toe out. So, but if you measure in degree, this will not matter, because a degree will always be a degree. This will, and in the end, the wheel angle, looking at this wheel, the millimeter and degree is still going to be the same. So let's go over an overview of the different angles. So when we do alignment, we talk about toe, and then we have toe in and toe out, which is positive and negative toe. We have the camber, which is positive camber and negative camber, depending on how, if the tires are facing outwards or inwards. We have a caster, which is based on the let's say, on the suspension joint axle, which is if it's more inwards leaning or outwards leaning, so negative and positive. We have a setback, which is the tires relating to each other. if one is a little bit in front or backwards than the other one. We have the thrust angle, which thrust angle is, let's say, that the angle that decide how the car is going to drive on the road. And if the car is going to be crabbing, so meaning that it still drives straight, but it will look a little bit on the right or on the left, driving forward. This will not be felt in the car, but it can be seen. It's like a crab. A crab always walks on the side, still walking forward, walking straight, let's say. So axle offset is if you have a difference between the back wheels and the front wheel in diagonally. So one is more on the side than the front wheel is more on the side than the back wheel. And we have KPI, which is also known as kingpin value. And then we have turn out on toe, which is tooth value, which is depending on the relation of how much one tire turn compared to the other. So to begin, let's start with the toe angle. So the toe, normally the manufacturers indicate the total toe when they specify their recommended value. So they always give you a total toe to follow, and the individual toe is really only used to let's say to get the steering wheel position right, to get the steering wheel correct. Because if you drive on the road, if you have individual toe, let's say different between on each side, this will not really matter, because when driving forward, it will still equally distribute between the two. So this is the same on both front and rear. So if the individual toe wouldn't distribute equally when driving, the car would turn itself. So even though the individual toe are not different, let's say, then there will be, when you drive, it will be distribute itself equally. And this is also one of the cause why the steering wheel might be, let's say, a little bit crooked or something after doing an adjustment. So a rule of thumb is to always aim to have the both sides as close to each other as possible, to be as little different as possible. And if you adjust, let's say if you have too much toe in, for example, which will normally result in that the tires wear more on the outside of the tire. And if you have too much toe out, this will normally result that the tire they wear more on the inside of the tire. But depending on how much it does, this is also related to how much the camber values are on the car. So when you do a toe angle, it's important to measure it on, or to have a look and to measure it on let's say all the tires. Because if it's say you have, for example, you have the pictures on the right. So if one of the car is toe in, is like right rear wheel. If you have toe in on the right rear wheel, it will turn. It will make the car turn to the right, let's say, a bit. And if you have, let's say, if you want to have this car go straight, you will have to, let's say, turn a little bit towards the left. And then as a result of this, then normally the steering wheel would end up being tilted for the left side in this case. And this will also result that the thrust angle will be wrong, and the car will then end up crabbing going forward on the road. So it's always important to, let's say, to have getting the steering straight. You always have to let's say do a four wheels alignment, and always try to get the two toes as equal, the individual toes equal as possible towards each other. And it's always important to separate the two values and make sure that they're evenly distributed. So the steering wheels But when the steering wheel is straight, so that's also important to put the steering wheel where you want it, you block it, and then you make sure that they're evenly distributed. So even if a car, let's say, on the lower picture is distributing completely right, this is, let's say, the perfect form. There cannot be an oblique, let's say, wear of the wheels, only because that the toe is wrong, because it always distributes evenly while driving forward. So it's always a combination, most likely it's a combination if you have oblique tire wear between the toe and the camber. So looking at going into the camber, so the camber is also normally measured on all wheels, backwards and forwards, and you have it's negative and positive camber, which is inwards or outwards. So generally, if you have too much negative camber, then you will have the tire wear will be more wear more on the insides. If you have the two, let's say, positive camber, it will wear more of the outside of the tire. Which, if you're looking at the figures, which become obvious. And of course, this is also depends on how much the wheels are, let's say, inclined in front of the toe values. So all these both are related. And it always helps to keep in mind that camber is a force. You can imagine it as a cone, as the below picture. That if you have the wrong, let's say, the camber, it will pull the car to the side, to the right, or the left, depending on the things. So if the difference between the cambers, the right and left, is too big, you will have the feeling that the car is pulling. You need to kind of hold the wheel in order for it not to pull on the side, or one side or another. So it's like a force that pushes the car if you have the wrong camber angle. So when you do the camber adjustment, one should also always aim to have as little difference between one side or the other as possible. So this is let's say it's difficult for to get the both tires to wear perfectly evenly, and it's also, let's say, and also having, if you have two different camber values, it will cause, as I've said, to make the car pull to one side or the other. So if you have, for example, the both wheels of the camber have a difference that makes the wheels tilt to the right, then the car, as you see on the picture above, the car will pull to the right. Seeing the wheels, it becomes obvious. So, and if there are some, let's say, let in some more people waiting in the lobby. So if there are allowed to have, let's say, some difference in the camber, can be, but it's better in that case to have that the camber difference is towards the left, because then the car strives towards the road slope. The road, in order for the water to get off the road is slightly tilted towards the right, let's say, slightly downhill tilting. So if normally there can be a little difference towards the left side, this will help to, let's say, to fight the road slope, let's say, and will push the car a little bit towards the road slope. So a little bit towards the left, it's okay. Normally, some cars can also have a difference up to 1 degree without the car is pulling. And some cars, even with a half degree, can have the pulling on the side. So it also depends on the car and so on. And let's say if you look at lowered cars, this will, if you lower a car, this will directly impact the let's say the camber values. So this will make the car to mostly wear out more of the inside like tires when the cars are lowered. This can be somewhat compensated with the toe values, but only to a certain extent. So looking at the caster angles, so caster is also, let's say, is measured only on the front wheels, and is let's say usually measured in minute degrees or decimal degrees. And there are some cars that also have the possibility to measure caster values also on the rear axle, but it's not included. Let's see here, let's say it's more of a turning steering geometrics. So most of the cars that have a, let's say, a positive caster angle, and some have more, some have less. It depends a little bit on the characteristics that the manufacturer wanted for the car. So in general, you can say that, let's say, if you have a large caster angle, it will make the car a bit more stable, but let's say sluggish. It will be heavier to steer the car, to steer it, let's say, but it will be more course stable. See, meet everyone. So it will be more course stable while driving. If you have a smaller caster angle, the car will be, let's say, easily steered, but not that course stable. So if you're looking at this, if you're looking at normally high performance car will have a larger caster angle, and let's say a city car and a smaller car, it will normally have a smaller caster angle that makes it easier to take the turns and so on within the city. So it depends on the characteristic that the manufacturer wanted for the car, let's say. So we have to keep in mind also as camber that caster is a force. So with a big caster angle, the car obviously always want to go straight. It doesn't want to turn. It want to go straight on. And with a small caster angle, the car easily wants to turn. So to think of a different way to think of this, you can think of two types of motorbikes. So, for example, if you have a shopper like a Harley Davidson, let's say, and more of a, let's say, a bigger car, the shopper, or you have a sport motorcycle, you have the difference. If you have the shoppers have normally the long fork with a large slope, which makes it really stable to drive straight ahead, but more difficult to turn, let's say. If you have a sport bike, on the other hand, you see the slope of the fork is normally smaller, and so then it does not seek to, let's say, drive straight, but it too stable, but it swings, it turns very easily. Say. So to have, let's say, if you have the too large difference between the caster difference between the right and left side, can also directly cause for the car to steer in any direction. Let's say if you have the two difference between right and left side, so it can make it a bit, let's say, unstable. So also, like with the camber and the toe angle, it's always important to strive to have as little difference between one side as the other. So between the side, you should always seek to have as little difference as possible. And also, what might impact the caster values depending on the height. So the height, for example, if the height of the car can affect if the car is, let's say, is high in the rear, then it would affect the caster angle negatively. If it's lower in the rear, then the caster angle will become more positive. So then we have a few angles that we will go over a bit faster. So we have the setback, which you have also measured on front and rear. See, let in more people, let me all. And this setback doesn't directly impact the tire wear or the driving behavior of the car. It's caused normally by, you know, by if there have been any accident or something that has changed the positions of the wheel, and it can the setbacks can let's say be affected even if the running angle is incorrect, let's say, can still be affected. So this is normally done for accident or something that happened with the car. So going to the most, let's say, in wheel alignment, the most important angle, and this is the angle that decides how the car is going to behave or drive. Let's say if it's going to drive forward, looking on the side, and so on. This is determine the direction we drive. So it decides if the car will go straight or be crabbing, like going straight but looking towards one or the other side. And this is controlled by the individual toes. And this is also why you always, if you think about it, you always start the wheel alignment from the back. So you always start on the rear axle, moving towards the front axle. And this is because the rear axle always control the thrust angle. So there, in order to have a good adjustment, you always start from the rear, let's say. And if the rear toe is evenly distributed between each other, the car will go straight and the thrust angle will be, let's say, 0. And also to keep in mind, the thrust angle is not to be confused with the symmetry line. You're normally talking about the symmetry line and the thrust angle. The symmetry line is the middle of the car. The thrust angle is the middle of the direction of the car where it will drive. So to separate these two normally can be easily, let's say, maybe easily confused. Then we have axle offset, which is the lateral relation between the tires. It doesn't affect per se the tire wear, but it shows the status of the car in general. If it has an accident, if it's something, this together with let's say the setback will give you a general idea of the status of the car. So this can also be some cars, if you have different rim sizes, it can also create a track difference and so on. And this can also be a cause for if the car is crabbing, looking on the side while going straight. Then we have KPI, which we're gonna go, this is kind of, let's say this is the road pin closure, the measurement for road pin closure to the tire in that lateral, let's say, so it's measured from the outer. So it's measured, let's say, from the upper and lower joints of the suspension. It's this angle with the modern forks of the car is a bit difficult to cope with, but it's not that easy to, let's say, change and adjust. You normally have to maybe change the parts if something is too wrong with it. But one should be aware of this angle and be vigilant to see if the difference is too big between the two sides, then something is wrong and need to be looked into further, let's say. But it's a bit complex angle, let's say. This angle is also measured directly when we're doing the caster swing. Okay, so then we have the turn out on toe or tooth, as it is referred to. So this is to which degree that the inner tire turns more than the outer. So when you can imagine if you would drive in a circle, both tires will make, let's say, 2 circles driving around. And this can be caused by like if the inner tire turns more than the outer tire, this will cause the outer tire to be dragged a little bit. So it doesn't turn in level with the inner wheel, and this will cause that when you turn, it will slightly drag one wheel a little bit. And if you have some weird toe angles and so on, this could be the cause. It could be caused by the turn out on toe, because certain toe angles might not be able to be explained, and looking for the reason, it might be caused of the turn out of toe. And this is also measured while you do the cutter swing. And this, in order to measure this angle, let's say effectively, you need to always do the cutter swing up to at least to 20 degrees. I normally suggest in general to always do 20 degrees, because if you do 10 degrees, you don't get all the values that you would like to measure. However, if you do all the way to 30 degrees, you might cause a restraint to the chassis of the car, and this might impact the values more than you would like to. So I always consider to keep it up to 20 degrees when you do the cutter swing. Okay, moving on. So then we have, let's say, a bit of oversteering and understeering, which means that if you have, let's say, too much toe in or toe out, you have, let's say that if you have, see, okay. Sorry, I will turn the video off so everyone can see. So generally, so toe in makes the cars, let's say, if you have toe in, it makes the car stable. But if you have too much toe in, can also make the car oversteered. So it means that the car will have the tendency to want to swing out the rear when you take a curve. But if you have, let's say, too much toe out, then the car may be, you know, while driving, it might feel a little bit uneasy while driving forward, but it wants to, let's say, turn very quickly, let's say. So, and also if you have too much, let's say too much toe in, it will make the car want to go straight. Let's say in a turn, it will turn, but it feels that the car would like to continue going straight. If you have too much toe out, it feels that the car it will turn easily, but the rear axle would like to, let's say, swing out a bit. So again, it's important to keep in mind with all these relations. What the impact is that there is always a connection between all the wheel angles, and all together, how the relation to these angles are together will determine how the car will behave on the road, say in general. So let's go into the special preparation. So on certain cars, have the request of measuring special measurement to confirm the status of the car. You have some manufacturers that ask you to measure the height of the car. Some ask you to load the car so it sinks down to a certain level before taking the alignment values. Mercedes, for example, use the Rhombus inclometer that asks you to take this inclometer values in order to see the status of the car, and depending on what value that you have on the car, the values that you will have and get suggested in the specs will change, so it will be different to this. And some has to have a certain level of fuel or liquid in the car before you continue, let's say, doing this. So it is, of course, always possible to skip these procedures if one would like to, but it is just, if one decides to skip it, it should be clear that let's say that this car, how this statement from the manufacturer, how it impacts the end result. It is possible to skip it and jump over it, but it should be clear, because this is in the end determined from the factory how they wanted the car to behave on the road. So if you skip it, one should be aware of what would be the end result if doing so. So we have also the cases depending on the market. This is mostly in the northern parts, in the colder areas, where we have a lot of problems with rust and so on. And this can cause a problem when you have to loosen up the adjustment points and whatnot. This can normally be solved by heat. And this is obviously, you can use the gas heat or you can use induction. So normally you need just a little bit of heat to make the balls, as they expand a little bit, and you will easier to release them and be able to work. You don't have to exchange the many parts. Many times the heat can actually solve these problems. And say you cannot loosen it, we have to change the part, but heat, a little bit of heat treatment make the material move and makes it easier to work with. And looking at two different ways, we have induction heating, we have a gas, let's say gas flame heating. The difference is, if you use a gas, you risk to, firstly, you heat a big area, you risk to injure, maybe harm some of the rubber points surround the area, and so on. So the best is always to use, let's say, induction heating, which allows you to locally heat the part that you want and will give you a higher control and not to harm the surrounding areas. It's a lot of pro and so on, but we're not going to go in this too much today. So I would like to, let's say, go over some problem solving and how to, let's say, prepare when you do the car. So the car, when we do the wheel alignment, the operator or the mechanic, the guy that makes the alignment adjustment, he should always do a test drive before he do the adjustment and after he do the adjustment. And this is to make sure that you as a let's say as a mechanic, as an operator, are always in control. So you always know what's the result. And also, it's better that, let's say, when you do a test drive before, you know how the car acts. When you do a test drive after you're done adjusting the car, if there would be something going wrong, you will notice it, not the customer. So it's always try to be in control, and thereby also control the level of quality going out. So when the customer gets his cars back, it goes as he expected to go. And also, you have, let's say, sometimes even if the adjustment is done correctly, the steering wheel can still be a little bit crooked, let's say. And this may be because of the car's, pulls a little bit, because you have certain wheel angles that cannot be adjusted. For example, you have maybe some rear axle things that may not be let's say, adjustable, and which makes impacts the result. Might be that you have one tire that rolls a little bit slower than the other. Also, this might cause the wheel to let's say, be a little bit oblique, just to mention a few. It's maybe not be felt directly that the car is pulling, but it normally notice that you will have to, turn the steering wheel in a different direction just to keep the car straight, even though it's a little bit, it still might be. So it is possible to, with adjust all the values around it to keep up for this. So, but it's so you can always maybe counter one not adjustable value with another adjustable angle, let's say. So just to end up, to get some, let's say, some examples. See at the meter one, we turn the camera off, and we will go into the last phase with some examples. So example one, we have, so if the car, let's say, pulls to the left, it might depend on the camber difference. As we talked before, the camber directly impacts this. The caster difference is so that the car strives to the left, or both the camber and the caster are affecting this. Maybe you have some of the tires on one side is rolling slower than the others, and this makes the car strive, let's say, pull to feel like it pulls to one side. Or you have too low air pressure, or you have maybe one of the brake is on one side, which gets the car to behave to pull to one side. Or you have an example, if the car is acting, let's say, worried on the road and feels a bit unstable. This can be because you have too much toe out. It makes it a bit worrisome. So, and then you have to see how does it wear on the tire? Does it wear excessively tires on the inside, etc.? And this also might be a fact that there are different types of tires on the car. So maybe if you have different manufacturers, different marks of types of tires of the car, this might also be a problem for the instability or the worrisome on the road of the behavior of the car. So, or the toe values are, or let's say, changed incorrectly. So the car has, let's say, as the car flex, let's say, springs, and this causes the steering geometry to be incorrect. Another example might be that if the car is wearing tires on the outside or on the left front tire, might be to the camber difference is too big, and also the car that probably has too much toe in. The problem may also be due to, let's say, to an incorrect tire. Again, if you have different tire and so on. And in this case, the car might also pull a little bit to the left. Maybe, let's say, sometimes it might not be felt too much inside because of the road slope. If it's to the left, because the road always leans a little bit towards the right. So if you have a pull towards the left, you would not feel it as much as you would if it is to the right. Because if it's to the right, it's going to follow the road slope. So with the road slope, it's going to be felt much more. So the car wears tires exterior on the outside, but the toe values are correct when measuring. So in this case, we go to the turnout on toe angle, which may be a cause of this. See, if you have certain things that the individual toe cannot be explained, it might be because of the toe. And the last one, you have, for example, if the car is lowered, it's going to wear much more on the inside, let's say, because you get the camber angles become much more negative. And let's say that you cannot maybe adjust the camber to the where you want it, and you can partially offset this problem with making the toe a little bit more positively, but not too much, because if you do it too much, it's going to change the characteristic of the car. So this is a few problem solving, just to give a few examples. And to summarize this and go into the manufacturer's recommended values, is that sometimes it's in board, one can ask, okay, how did they think here? How does these values make sense? But sometimes they can recommend a very large, let's say, large negative toe, and additionally vary a negative camber and so on, which will be certain that the car will wear more tire wear, let's say, will wear the tire faster of the inside and so on. But sometimes the manufacturer can overlook this in order to, because they're looking for a different driving behavior, driving characteristic of the car per se. So it depends on what the manufacturer wanted from the car. And in the end, it's up to the operator to decide on how to deal with this. If you would like to, for the car to consume less tires, or the car to behave as the manufacturer wanted it to behave on the road. But it's always a good rule of thumb to always be vigilant and to, let's say, follow the manufacturer's indications as much as possible, but to not ruin let's say the car's driving characteristic. And also to keep in mind about so be also vigilant, let's say, about the negative toe, because negative toe can wear the inside of the tire, but and in one to keep in mind that if it's too much, maybe it'd be good, you can put it to the toe of the car closer to zero, but it's always important to keep in mind all the values together, let's say, when we do an alignment adjustment. So that's sum up, let's say, to get the key points is to keep in mind to always try to keep the angles, the difference between the sides, as small as possible. Always measure the four wheels and always start adjusting from the rear axle, and always primarily follow the manufacturer's recommendations and the measurement and the loading and recommendations and so on. And always keep in mind that all angles are impacting more or less each other. So that's it for this, let's say, Thursday mornings or afternoon training. I hope, I feel free to ask as many questions and so on as you want, and leave feedback, or you can do it here in the chat, or you can write directly to Tu and so on. If there's, I hope it's been helpful and useful. And as I say, this is also something new for us, let's say, in general. So all feedback on what we can think of and what we can do to improve is very welcome. And I would like to thank everyone for participating and taking the time to join us. Let's see. I will look over the chat and see if there's any questions and try to answer as many of them as possible before we finish.